Hello my dear students, welcome to Fluid Mechanics Lecture Series. I am your SumamMiss. Today we are going to discuss different type of problems that is we can see in the engineering field related to viscosity. The property viscosity that is coming to picture when the fluid is under motion, and it is the measure of resistance to deformation. So viscosity is defined as the resistance offered by one layer of fluid over the other, and this resistance is coming when the fluid is in motion, and it is due to the cohesive forces and the momentum transfer between the adjacent layers. So before going to discuss about the problems, first of all we can discuss the unit of viscosity. The Newton's law of viscosity, that is tau equal to mu into du by dy, where tau is the shear stress and mu is the viscosity and du by dy is the velocity gradient. So in Newton's law of viscosity, or for Newtonian fluid, the shear stress is maintaining a linear relationship with the velocity gradient. Or in other words, we can define the unit of viscosity as it is the shear stress producing unit velocity gradient. Or in other words, so the coefficient of dynamic viscosity can be defined as the shear force per unit area. Shear force per unit area means the shear stress required to drag one layer of fluid with unit velocity past another layer a unit distance. So that means viscosity means it is the shear stress required to produce unit velocity gradient. So if you are elaborating this, that is mu equal to shear stress by velocity gradient. So if you are expanding, we will get it is shear stress means F by A. So unit of F means it is Newton, A is meter square, and unit of velocity, that is meter per second, and dy the unit is meter. So dynamic viscosity mu, the unit is Newton per meter square into second, or it is called Pascal second. So Newton per meter square is Pascal, so it is Pascal second. So the unit of dynamic viscosity is Pascal second. In engineering applications, we have to come across different type of small unit. So one of the small unit commonly used to represent viscosity is poise. So the relationship is 10 poise equal to 1 Pascal second, and still smaller unit, that is centipoise. So 100 centipoise equal to 1 poise. All of you please be careful about the conversion, and if the conversion is not known to you, then it is very difficult to work out the problems. In fluid mechanics and as well as in heat transfer problems, another type of common unit that we are using, that is kinematic viscosity. So kinematic viscosity is represented by mu by rho. So what is mu? Mu is the dynamic viscosity and rho is the density. We have to divide Pascal second, or we have to divide Newton second per meter square by kilogram per meter cube. So whenever you are relating Newton and kilogram, you have to make proper conversions. Newton is related to kilogram by means in such a way that for 1 kilogram mass, if you are giving g acceleration, the resulting force is Newton. We can find out the unit of kinematic viscosity as meter per second, or smaller unit is centimeter per second, or it is called Stoke. So this is related to the movement of the vehicle over a sloping plane. So here you can see a sloping plane which makes an angle theta with respect to horizontal, and a body that is moving. The weight of this body that is acting downward, this gap is filled with some oil. So its viscosity is given as 0.15 Pascal second. So the weight of the body that is acting downward, and the component of the weight that is acting tangentially over this plane, which causes the motion. So here we are going to find out the velocity of this block. So one of the advice is, before doing any problems, first thing is we have to be careful about the data. You copy down all data, and then you have to convert all the data into the relevant unit. Here all informations are given. So weight is given as 60 Newton, and area of the plate is given here, and this gap is given as 0.0125 mm. All these data you can copy down, and you have to convert that into proper unit. So gap is given in mm. So what you have to do, you have to convert that into meter. So all data is now converted into the proper units. Now coming to the equation, because we have to find out the steady velocity. So which equation we can use? So our equation is Newton's law of viscosity is tau equal to mu into du by dy. So here y is given to you because this gap is given to you, and viscosity that is also given to you. Okay, so this is a viscosity. We are interested to find out this steady velocity by which this block is moving. How will you calculate shear stress? Shear stress means shear force by area. So in this problem, shear force is not given directly. Since the weight of the block that is acting downward and the slope is of this plane that is equal to theta, so the component of this weight in the direction of the motion, that is the shear force. So that can be calculated as F equal to W sine theta. Okay, so this is the component of the weight in the direction of the motion. So F equal to W sine theta. So we can calculate this. Next step is to calculate the shear stress. So shear stress equal to force divided by the contact area. So contact area means this area. So it is given that the block slides with this face. So this is the contact area which is facing the direction of the motion. So this contact area equal to 0.4 meter into 0.1 meter. So that we can calculate it as 0.04 meter square. So if based on this equation we calculate shear stress here, we know this value here, and these informations are available with us. Now the only problem is to calculate du. So we can substitute the shear stress and mu and dy in this equation, and we can calculate u. So u can be calculated as, so this is one of the typical problem we can experience in the field. This type of problem commonly you can see whenever the vehicle is moving over a sloping plane. So next problem mostly you can commonly see in automobile. So here a shaft that is rotating within another shaft. So the shaft diameter is given, it is given as 25 mm. Now this is rotating within another shaft. Speed of this rotation is given as 600 rpm. Length of this bearing that is given as 80 mm. In between this anode space here is filled with oil. So this oil film has the thickness of 0.15 mm, and the viscosity of the oil that is given directly as 0.05 Newton seconds per meter square. Now in this problem we are interested to find out the torque required to overcome the fluid resistance and the corresponding power loss. How will you calculate torque? Torque equal to force into R or shear force into R. Before start doing the problems, first of all we have to copy down the data and we have to convert all the units into the corresponding units. This diameter is given in mm and length is given in mm, and anode space, this thickness that is also given in mm. So all these values we have to convert into meter. Then speed is given. Now in order to work out this problem, torque can be calculated by force into R. How will you calculate the force? So the only equation available with us, tau equal to mu into du by dy. So if you want to calculate shear stress, then what we have to do, we need viscosity and we need the tangential velocity and we need this gap. This information is with us, but we don't have any idea about this tangential velocity. So how will you calculate tangential velocity? Though tangential velocity is not given, but we know that the shaft is rotating with a speed of 600 rpm. So we can calculate the tangential velocity by using the equation, that is u equal to r omega. This is tangential velocity at the shaft surface, u equal to r into omega. So omega, that is the angular velocity. How will you calculate omega? Since rotation speed is given, omega can be calculated as 2 pi n by 60, where n is the rotation speed that is given as 600 rpm. So tangential velocity we can calculate it by r into, r means d by 2, into the angular velocity. So tangential velocity is this. Now in this equation, this value is known and this value is known, where this value we calculated. So what we can do, next step is to calculate the shear stress. So shear stress can be calculated, that is equal to mu into du by dy, that is equal to 261.67 Newton per meter square. So shear stress is known. Now shear force equal to shear stress multiplied with the area. So here the contact area means the surface area of this shaft. How will you find out surface area of the shaft? That is, it is rotating within the another shaft and this gap is filled with oil. So that means the surface area inner shaft can be calculated by the perimeter multiplied with the length. So that is equation is pi dl. So shear stress multiplied with the contact area, that is called pi dl, that will give you the shear force. So shear force can be calculated as shear force equal to shear stress into area. So shear stress we calculated already. So this multiplied with pi dl give you the shear force. So now shear force is also calculated. Now we can calculate torque. How will you calculate torque? Torque equal to force into R. So torque T, that is equal to shear force we already calculated, shear force into D by 2. So that is 0.02 Newton meter. Next part is to calculate the corresponding power loss. So power loss equal to torque into omega. So power loss can be calculated as torque. Okay, so this is the rotational force multiplied with the angular velocity. So that is equal to 1.256 watt. So this much energy that is getting lost because of the friction. We can select different type of fluids which has low viscosity so that power loss is minimum. Here a metal plate we are suspending within the fluid, and this plate is moving with a velocity 0.1 meter per second, and we are interested to keep this plate at the middle of the gap. So gap is filled with an oil or specific gravity 0.9. Remember, here specific weight is not given but specific gravity is given. The purpose of this problem is to find out the force required assuming the plate to remain midway in the gap. So if we want to keep the plate at the middle of the gap, how much force is required? So if you want to find out how much force required to keep this plate at the middle portion, then we have to see what are the forces acting on the system. So here you can see that the plate of the metal is having 1 meter by 1 meter into 2 mm. So 2 mm, that is this thickness. So total gap is given as 20 mm. So here from the middle portion to here up to 10 mm. Since the thickness of the plate is 2 mm, so the gap this side is 9 mm and this side is 9 mm. So total gap that is equal to 20 mm, and we are interested to find out the force required to keep this metal plate at the middle of the gap. So here you can see that weight of this metal plate that is acting downward. Since this metal plate is within the fluid, there is an upthrust that is acting on this block. So the upthrust is equal to the volume of this fluid displaced by this metal block multiplied with the specific weight of the corresponding fluid. So this upthrust can be calculated as multiplied the volume of this metal block and the specific weight of the corresponding fluid. Before start doing the problem, again I am starting, we have to copy down all data and we have to convert that into proper unit. So in this problem, specific gravity is given. So what we require is specific weight. So specific weight of this oil can be calculated as specific gravity of the oil multiplied with specific weight of water. So you obtain value is 8829 Newton per meter cube. So in order to find out upthrust, next part is to calculate the volume of the metal, because so volume of the liquid displaced by the metal that is equal to the volume of this metal. So volume of the liquid displaced that is equal to the volume of the plate equal to 0.002 meter cube per second, and upthrust equal to volume multiplied with the specific weight. So volume multiplied with specific weight will give you the upthrust. So upthrust that is acting upward, whereas weight of the body that is acting downward. So the unbalanced force that is acting downward equal to weight of the plate minus upthrust. So that is also acting downward because weight is more. So the next force that is coming here is the viscous resistance. So since this plate is moving in this direction, the viscous resistance that is acting in the opposite direction, or it is called drag force. So how will you find out drag force? Drag force equal to the shear force or shear stress into area. Here there is viscosity oil is given to you and velocity is given and you know the gap. So we can calculate the viscous resistance or the shear force. So shear stress multiplied with the surface area will give you the viscous force. So here two areas are Okay, so that's why we have to consider these two areas where the viscous resistance is occurring. So shear stress can be calculated as mu into du by dy. So dy, that is the gap, that is equal to 9 mm, and velocity is given as 0.1 meter per second. So we can calculate tau. Tau can be calculated. So viscous resistance equal to tau into twice area. Tau equal to mu into du by dy. So this is tau, that is mu into du by dy multiplied with twice area, because here the two sides are in contact with the fluids. So 2 into these two sides, 1 into 1. So that is equal to viscous resistance. So this viscous resistance, that is also in the downward direction. So if you want to keep this metal plate at the middle, then we have to apply a force in the opposite direction. So total unbalanced force, that is equal to, this is the weight component and this is the resistance offered by the viscosity of the fluid. So total force we have to apply so that we are able to keep this metal plate within the middle gap, that is equal to summation of this unbalanced force and the viscous resistance. So that is equal to this 60.112. So by summing these two values, so this is the total force required to keep this metal plate at the middle, but it should act in the opposite direction. Okay, so this is somewhat interesting. So this is also having some application in the engineering field. Next problem what we are going to discuss. There is a closed conduit and some external body that is moving through it. So how much resistance it is getting, or what is the total drag force experienced by this body when it is moving through a fluid which is enclosed within the closed system. So here we are considering two fixed plate and a square plate is moving through the fluid and it is not flowing through the middle. Here this is a moving plate and the gap from the bottom plate, that is less compared to the gap from the top plate. That is why shear force that is acting on this side and this side both are different. So these are the gaps y1 and y2, the two gaps. So it is given as y1 is given as 0.07 meter and y2 that can be calculated by subtracting from the total gap. So total gap is given as 0.25 meter. So before start doing the problems, what we can do is copy down all data and we have to convert all the data to the relevant unit. So here the viscosity is given to 0.46 poise. So that should be converted into Pascal second. Now our data are ready, so we can directly use the equation. But the only thing is this plate is moving not through the middle, but it is nearer to the sides. So that means tau 1 and tau 2 are different. Tau 1 is corresponding to this y1, whereas tau 2 is corresponding to this y2. Tau 1 can be calculated as mu into du by d1. So that is equal to 0.657 Newton per meter square. And tau 2 is corresponding to this y2. So tau 2 can be calculated as mu into du by dy2. So that is equal to 0.256 Newton per meter square. So total shear stress equal to tau 1 plus tau 2. So that is multiplied with the contact area, that will give you the drag force. So tau 1 plus tau 2 into area, because we are already considering two phases. Tau 1 we are considering this phase and tau 2 we are considering this phase. So since it is a square plate, so total drag force multiplied with the area will give you the drag force. So total drag force equal to 0.3285 Newton. So how much force is experienced when a solid body that is moving through a fluid which is enclosed within a closed conduit or closed system? That can be find out by using this problem. So far we have discussed different type of typical problems that we are experiencing in the field. So be thorough with the units and have a physical awareness so that you won't make any mistakes. So with that, thank you.